All right.
Okay. Can everyone see my stream? Okay. Good evening, everybody. Welcome to the AP Chemistry Seminar. So we'll be covering the content of this course, some study tips, and also the exam itself. We'll be giving you some info about the exam. So first, the content of the exam and the course. There's 9 units according to the AP Classroom. So you have atomic structure and properties, molecular and ionic compound structure and properties, intermolecular forces and properties, chemical reactions, kinetics, thermodynamics, equilibrium, acids and bases, and applications of thermodynamics. They each weigh differently on the MCQ. As you can see, Unit 3 and Unit 8 are weighed higher than the rest. Although the College Board separates the AP Chemistry curriculum into 9 units, your teacher will most likely not teach this accordingly to the AP Classroom. They'll usually use a general chemistry textbook, and it'll usually be around like 20 units. So, Anyway, units 1 to 3. So unit 1 is atomic structures and properties. Here are the major concepts. You have moles, the molar mass, spectroscopy, elemental composition of substances, atomic structure, periodic table trends, valence electrons, and ionic compounds. Andrew and our opinion is that unit 1 is by far, it's the easiest. This unit, along with unit 2, are like the fundamental units. Unit 3 is also very important as well, but I think unit 1 and 2 are the most important. You'll need to know these two, but they'll usually be these will usually probably be reviewed from your honors chemistry information. You'll probably already know these two mainly, especially unit 1. So don't worry about this one as much. This will most likely be the easiest one. Unit 2 is also quite easy. However, you should look out for resonance, formal charge, the Vesper theory, and hybridization. These 4 concepts are a little bit more challenging than the rest. Anyway, unit 3 is intermolecular forces. And major concepts are, the intermolecular forces. They'll also be called van der Waals forces. Properties of solids, liquids, and gases. Plasma will not be covered in AP chemistry. The ideal gas law, kinetic molecular theory, real gases, solutions, mixtures, and separating mixtures, also method of separating them, which is chromatography, and also solubility. Solubility shows up in a lot of units. Unit 3 it's definitely up from these two. However, unit 3 is also not the most difficult. The ideal gas law is commonly tested on AP exam. You have to know the ideal gas law. Okay.
All right. Adding on to the last part, like the ideal gas law also it's helpful because it also some other concepts you need to know the ideal gas law in order to solve those problems. So like a lot of the stuff is like together, but you won't be learning it that way. Unit 4 is about chemical reactions in aqueous solutions. So it's mainly about chemical reactions, net ionic equations, representation of equations. So that's like adding on to it's going more in depth with like reactivity, stoichiometry, titration, types of chemical reactions, acid and base reactions, which you will go an entire unit about later, and redox reactions. This unit is again, it's like ramping up in difficulty. Unit 4 is harder than unit 3. And a lot of this information begins not being taught in like the NC honors curriculum, for example. I think there's a very brief introduction to redox in honors chemistry, but you go a lot more in depth in AP chemistry. Unit 5, you begin to talk about kinetics, so reaction rates, rate law, concentrations, and change versus time, which has a lot of different formulas. Elementary reactions, collision theory, reaction energy profiles, like catalysts. I don't know how to pronounce this word, but it's basically just like using catalysts in like reactions and how it affects the energy. And basically, and I think this unit is probably the hardest one you'll have in your first semester. I think you usually end off on kinetics, and it's fairly hard, especially because there's a lot of information, and it's like it's very different than honors chemistry. It's like the most, I think, if it's especially because if you're taking AP chemistry, it's most likely your first AP science. It's very different than like the concept is a bit different. For unit 6, thermodynamics, part 1, uh, it goes into talking about like energy, like heat energy mainly. So it talks about endothermic and exothermic processes. So like identifying those. I think you should have done a bit of that in honors chemistry. Uh, energy diagrams, which like you just draw out like how the energy moves. That relates back to the catalyst and like the energy required to do the reaction. Heat transfer, calorimetry, heat capacity, phase changes, enthalpy, bond enthalpy, enthalpy of formation. So it's just like it introduces like the concept of energy in determining if like how if and how these chemicals will react with each other. I think personally, me and Derek agreed that this unit 6 was a bit simpler than unit 5, but I don't. It's much harder than like something like unit 1 or 2. Next slide.
Okay, so oops, sorry. Anyway, equilibrium. So equilibrium is like it's very important. You'll need it a lot in unit 8, which is the hardest unit, like in my opinion, and it's by far the hardest unit. Unit 7 covers reversible reactions, equilibrium, reaction quotients, the equilibrium constant. The equilibrium constant is a very big concept. It's used in like many units. Like you'll need to know equilibrium constant well. It'll also be tested quite a lot on the AP exam. Le Chatelier's principle. This will also be quite important. This is not, there's no calculations to do with this, but it's quite easy, but it is pretty useful. Solubility, equilibria, common ion effect, pH solubility, free energy of dissolution. The common ion effect and pH insolubility, these are like very, very tied in with unit 8. So anyway, the difficulty for this unit is like about a 7 out of 10. It's very important, but it's not insanely difficult. It's harder than thermodynamics unit 6, but it's not nearly as bad as unit 8, which is the next one. So in unit 8 is acids and bases. The major concepts are acids and bases, of course, pH and pOH, which is basically measuring the strength of an acid, the concentration of acid. Weak versus strong acids and bases. Once you get to this, I think weak is weak. Once you deal with like weak acids, it starts to become a little more confusing. There'll be a lot of calculations and a lot of concepts that you have to like memorize and know very well thoroughly, especially once you move on to buffers. If you don't know, if you don't have a strong foundation of like weak acids and the earlier stuff in unit 8 and unit 7, like the entirety of unit 7, buffers will be very, very difficult. Acid-base titrations is also a very, very difficult concept, especially like the calculations and stuff. Structures of acids and bases, pKa, which is another like way of measuring the strength of an acid that has to deal with unit 7. The Henderson-Hasselbalch equation, and buffering capacity. Unit 8 is definitely very, very hard. I would give it, or me and Andrew would give it a 10 out of 10 in difficulty. It's very tested upon on the unit or in the AP exam. Buffers, the Henderson-Hasselbalch equation, buffering capacity, acid-base titrations, weak acids, and pKa all require concepts from the first part of Unit 8 and Unit 7. So Unit 9 is thermodynamics part 2. It also includes some stuff about electricity and like electricity and chemistry and stuff. It has to do with entropy, absolute entropy, the change in entropy, Gibbs free energy, thermodynamic favorability, equilibrium, which is ties back into Unit 7, galvanic and electrolytic cells, cell potential, free energy, cell potential in non-standard conditions, electrolysis, and Faraday's law. So many of the electrochemistry concepts, they'll require thermodynamics, especially the earlier part of Unit 9. Unit 9 is also probably one of the most tested upon units of all 9 units. It's not extremely difficult, but it is quite hard. There's a lot of formulas that you have to memorize for this unit. And yeah. So here are the 6 science practices that the College Board wants you to know for like the AP chemistry course. You're designed to learn these. The course is designed for you to learn these. And at least for me, most of these skills were learned during the lab portion of the class. They required you to like write and like read procedures and lab reports and stuff like that. These practices will be very necessary for the AP exam, especially for the FRQ. So representations and models, describe models and representations of data, which is weighed not too much on the MCQ and very little on the FRQ. Question and method, create and answer scientific questions and determine methods. This is also not much on the MCQ, a little bit more on the FRQ. Representing data, nothing on the MCQ. And it's a little more on the FRQ. I think math routines is the most tested on for the FRQ. You'll need a lot of calculations in FRQ. That's why they give you a calculator. For MCQ, the calculations are generally pretty simple, and argumentation is a lot more in FRQ than MCQ. So the exam format, the AP chemistry exam is 3 hours and 15 minutes long. The exam consists of an MCQ section and an FRQ section. The MCQ is 60 questions in 90 minutes. FRQ is 7 questions in 105 minutes. There will be a break in between these two like sections. Your proctor would give you like a 15-minute break usually. Both sections are worth 50% of your final score. Okay.
All right, so going on to talk about more about the exam format. So there will be a total of, I think, 60 questions on the MCQ part of the exam, but only 50 of them will count. So it's a bit like how in some tests they will mix in some like future questions just to like get a gauge on how students are performing on them. So only 50 of them will count, and each question will be worth around 1% of your total final score of the exam. And especially for multiple choice, these points should be more easily gotten as long as you study well and like know the concepts, as there's very little like you know how these will be graded. This either your choice is correct or it's incorrect. But for the free response, it's a bit different. So for your free response, your final composite score will be 46 points. So there will be 3 long essay questions, which are formatted as like the first 3 questions you see. There will usually be about one. No. So this will have like one main problem, like one scenario, and it'll have a lot of follow-up questions. So I'm not going to give an example because it'll probably take too long, but there will be like it'll talk about something like, let's say, the ideal gas law, and then after that it'll ask a question about maybe, let's say, rate law or thermodynamics, and it'll just keep on going one after another, and it'll probably ask around 4 or 5 of those questions. And what happens is every time you write a response, so with like the long essay question, there'll be like A, B, C, D. So once you answer the first question, they'll usually like look for something like significant figures, or let's say like if you address a certain point, right? So like if it was the ideal gas law, right? They might want me to write out PV to just show that I know what I'm doing and it's just not a random guess, or I'm cheating. So what's very, very important about doing the free response is making sure your work is clear. You want to mention these terms, these like terms, just so you get the point. Like, even if it makes sense without it, probably, like, they're just like, the graders are there to give you the point if they see what they want to see. So just make sure you write down anything you think might be on the rubric, right? So if it's PVNRT, right, the ideal gas law, or maybe if it's the like the Hasselbalch equation, or if it's or if it's like one of the other equations just given to you on your handout sheet, like anything, just make sure to write it down just to get those points. After that, you have your 4 short answer questions, which are graded out of 4 points each. It's not, I think the short answer questions are more straightforward than the long essay questions. Sometimes they're simpler, sometimes usually they're not harder. And usually for these short answer questions, you have to be very careful about your calculations, because I think most of the time that's where the points come from. And so each one of these points for the free response are worth slightly more than the MCQ. So the MCQ is 50 out of 50 points, and this is out of 46 points, but they'll basically like have like a multiplier for these FRQ points. So it'll be 50-50 in your final. Yeah. And going back to like how to do free response, you want to put as much of the like important information at the front as possible, and you want to be, I think you guys went over this last year about dimensional analysis. I don't think it was graded as hardly last year, but dimensional analysis is super, super, super important. Like, especially in AP chemistry, like maybe in actual chemistry, it's not as important, but in AP chemistry, they grade this super hard. They're like, if you didn't show out your workflow, they'll just take off the point. Even if it like everything else makes sense, they'll just take off 1 point there. And it's, yeah. But especially with the FRQ, you got to realize that you're going to lose some points here or there. I think our class, and I think Derek's class, when we did these FRQs, I don't think anybody got a perfect score. I think the high score that someone got was a 43 out of 46. So it's extremely hard to do these free responses. Get perfect scores in these free responses, but just make sure to try your best, because this is mainly like the FRQ will decide whether or not you get a 5 on the exam. So these are some concepts that we found that like we agreed that these are very prominent on the AP exam. So dimensional analysis and stoichiometry, just like changing between different units is very important for like, it comes up very commonly. Sometimes this will be like a side note, right? Like they'll have like a question, and then you'll have to do some dimensional analysis to change the units. You don't have to worry too much about dimensional analysis in like, let's say, the MCQ, but especially for the FRQ, like dimensional analysis comes up a lot. Thermodynamics, enthalpy, entropy, Gibbs free energy. So you guys will learn more about this, but the one important concept to like, just it might not make too much sense right now, but you just have to understand, like, I think there's this concept in engineering where it's like electricity, like energy always wants to take the path of least resistance. And throughout your course, just think about like the concept of like wanting to do the least work as possible. Like the path of least resistance is like, especially with something like enthalpy or Gibbs free energy, it's like always that activation energy, like always where like as long as you meet the minimum, just assume that everything goes, or like as long as if it doesn't meet the minimum, then nothing happens. Like you just have to remember that like concept of minimum energy. For electrochemistry, this is it. There's always one on the free response, I think, for like the past 20 years or whatever. I'm not sure further past than that, but for electrochemistry, you can always get some free points as long as you know like your vocabulary for electrochemistry. So like electrochemistry, I think they'll talk about the anode and the cathode, and as long as you know which one is which, and you know like which way the electrons are flowing, like that's always a free point that you can get. Like it's always there. Trust me, it's always there. Uh, Balancing redox reactions is also something that comes up a lot. Is just balancing equations. I think that's something that you will learn throughout your year in AP chemistry just because of the amount of practice that you will get through homework and stuff like that. Aqueous solution reactions comes up a lot, but it's more, it's usually not like a main concept. It's more like it comes up a lot as in like there will be a lot of aqueous solution reactions, but they might not always ask you about how to balance it or like what's happening, but more like conceptual ideas like how many like electrons are being transferred, right? Like what would like going back into electrochemistry, right? Like in an aqueous solution reaction, like how long would this take if this amount of electrons were given, like put into the system, or if there's like a battery or something. Lewis structures. With Lewis structures, I think that it's again, it's like electrochemistry. It's 3 points. There's you basically just draw lines, and I think there's a like stuff like the Vesper model as well. I didn't write that down, but those are 3 points. It's literally just names. Like as long as you can remember, I think it's like 6 names, and there's 3 names for every. So there's like 18 things total, and you can like guarantee yourself like 4 or 5% on the exam, which doesn't sound doesn't sound like a lot, but it matters a lot. Ideal gas law, we went over this. Can't stress this enough. It matters so much. There's so many questions that just rely on you to like, so like I think most of the time it like you use the pressure, and volume and the temperature to determine the number of moles, or sometimes it'll be like what it will like it. There's like this direct. There's some other like derivative laws from the ideal gas law, like the like how P is always inversely proportional to V, or like T is always proportional to P or V, like as long as one of them is held constant. So yeah, as long as you remember that, you should. That's like there's a lot that's just like it's a simple law. It's a simple equation. Just as long as you remember it, if you get stuck, just think about it. Something might work with that. Ionization energy is basically activation energy, and you'll learn more about that in, I think, kinetics or intermolecular. I think it's like intermolecular forces, but yeah, rate laws kind of important. It appears constantly, but the handout that they give you covers most of that. These are just some exam tips for the actual exam. So MCQ questions, mostly conceptual. If you're trying to study for the MCQ, flashcards are great. Practice questions are great. Previous exams are great. Your AP Classroom, great resource for that as well. Calculators are not allowed in the MCQ. So most of the MCQ questions will not require too like big calculations. So like you don't have to worry too much about like your like internal math, like you won't have to worry too much about like math. It's mostly conceptual. You want to answer every question. This is not like the AMC 10 where if you don't answer a question, you get like 25%. No, you don't get anything for not answering a question. So guess your best choice. I'm pretty sure there's like studies done about like how your initial guess is always probably more right. Actually, no, I don't know, but just guess based off your gut feeling if you don't have a strict answer. And this is the most important: skip hard questions and do them later, right? Like if you are like if you are stuck on a question, it's worth the same as the next question. So there's no point on being stuck on one question and just wasting the time for every other question. Like don't be too hung up on like a single question for the MCQ. It's like you can miss 30 of them and still get a 5. It's not a big deal. When you're studying for the FRQ, you should practice with the released AP chemistry FRQs. Review your lab procedures, data, and calculations in the lab, just to like get the idea of like how it should be done. Long FRQ questions simulate solving problems with data, and like it long FRQ questions more simulate like being like actually in a lab, right? Like where you have follow-up questions, like yeah. Uh if you forget anything on the test, there are reference tables. Honestly, you should there use those. They give you a lot of information. I can't tell you how many times it saved me. Like sometimes I would take tests and like this isn't during the AP test, but I would take tests during the year and I would look at the reference table and like kind of figure it out from the reference table. Like I should, this is probably not a good thing, but like it gives you a lot of information is my point. Uh you make sure to read every question carefully. There have been many times where I've lost points on practice FRQs where I would answer the question correct. I would answer a question correctly, but it wouldn't be like in the right unit or like explained in the right way. So you have to be careful not only to get the answer correct, but to get your reasoning right with it too. Uh, some questions are worth more than 1 point. Yeah, that's an important point as well. Like some of the questions, like I don't know if I couldn't tell, but some of the questions they would have like kind of like a 2 points for each of the questions. It would be like there would be like a explanation and a follow-up, or maybe like a formula and then a follow through. So it's like the answer is always worth 1 point, and then sometimes the procedure is worth 1 point as well. And sometimes when you don't know how to when you think you know how to solve a problem and your answer looks like completely wrong, like just leave your work. Like you don't have to erase everything, because some questions only like some questions are only graded on the procedure. So I mean, there's uh I yeah, just always leave your work on the thing just in case it gets you a free point. And unlike MCQs, FRQs give you a calculator because they have a lot of calculations. Like maybe your mental math is great, but I don't think it's like calculators are always more accurate than your mental math. So if you have the time, use a calculator. If you have the time, you can maybe cross-check it with mental math, but a calculator is always great. Like personally, what I do is I use my calculator. I do it in my head to get like an estimate, like very rough estimate of where the number should be about, and then using a calculator to like follow up on that. So it's like, oh, I think it's going to be in like the maybe like 80 to 100 liter range. And then I'd use my calculator and be like 96. And I'll be like, okay, that's like kind of there. Right. So it's just like, it's just to make sure that you didn't miss input in your calculator. At least, yeah, that's what I do. All right. So yeah. Any questions?
I can post the slides again in the chat if you guys want to like look at it yourself. Hold up. Yeah. Um East Chapel High, I don't know. I think you can ask Andrew. Or wait, where do you go? You can ask Andrew. He did he goes to East. I go to Chapel Hill High School. Chapel High School, they use like a Zumdahl 7th edition general chemistry textbook. I believe that's what it's called. Yeah.
If you go to East, I don't know if anyone here does, but I have the online textbook. So if you ever need that. But at East we use the Chemistry, the Central Science 14th edition. It's by Pearson. It's the Brown LeMay one. It's published in like 2000 or something. It's very old. But yeah, I have the entire textbook if anyone wants it.
Yeah,
like, just like shoot me an email. I'll send the thing to you. I don't know if
yeah,
that's like illegal, but
If you go to Chapel High School, I can also send you the Chapel High School textbook, assuming it's the same teacher again next year. Or that's from my school. I don't know about. I can if you go to Chapel High School, I can send. If anyone here goes to Chapel High School, I can send you the Chapel High School, the textbook that our teacher used. But I don't. For East, it's an online textbook. Um, I don't. I'm not sure if it's exclusively, but I guess the newer the better.
So basically, the difference between like the textbooks is like the core information remains the same, but then like the way they explain some of the things and some of the practice questions will be a bit different.
They also might have a little bit more info in the newer editions.
Yeah, they'll have like more up-to-date info. So like for example, the earlier versions of the chemistry textbooks might have uh like a diff like a I don't know, like a different concepts because like chemistry is kind of like not evolving too much, but there are new concepts being discovered every day, and they will like the newer versions have the most up-to-date info. So yeah.
Hold on, I'm looking at your screenshot. I think that's the one, the East.
Yeah, that's the East textbook.
Okay,
All
so
right.
I guess we're done.
Yeah. Stop recording.